Hi everyone. So we are already going to talking about the concept of derivative of a function, right? Differentiation of a function. So means that a function of a derivative of a functions, which is actually we call it as the first principle. Okay, the first principle. So this is always that every student that know how to do differentiation, they must know the concept of first principle here. So what is the first principle here? So actually I want to derive the formula for first principle. So this is the very first principle, means that the first, okay, as the most basic form of derivative of a function. Okay, so let's say you look at the curve here, right? You look at the curve here. So this curve, we have 2 points. We have 2 points. We have a point P and we have point Q, right? Let's assume that the point P to be a fixed point, right? It's a fixed point, and Q is a neighboring point. Neighboring point means here jiran. Okay, not neighboring point means that it's a point that with x plus h. So means that it's slightly different from x. So just by adding a h here, so means the distance here will be h, right? The distance here from x to x plus h will be h. You take x plus h minus x, you will getting the distance h. So h represent the distance between point P and point Q. So I'm going to label the point Q with, alright, I'm going to label the point Q with x plus h, right? As you know that the coordinate x here will be x plus h here. So it means that it will be x plus h. So, and of course the function here, the value of y must be fx plus h, right? Fx plus h. So very simple. So the x coordinate is x plus h and the y value will be fx plus h. How about point P? It's the same. So the coordinate here will be defined as x and fx, right? Fx here. So, okay. So I'm going to draw a line joining P and Q. Alright, so I'm putting this point here, the P is x and fx. Alright, fx here. So I'm going to draw a line that joining the point P, to point Q. Right, joining point P to point Q. So this line that intersect at 2 points, this is a chord. It's a chord. So it's a chord. So and this line is a secant line. Okay, S-E-C-A-N-T, secant line. So now you have this line. So of course this line you will have gradient between these 2 points, right? The gradient between line P and Q. The gradient here. So the gradient of PQ. The gradient of PQ, I'm going to introduce you the concepts here, alright? You be patient and watching the video and you will understand what I mean here. So how to find the gradient of PQ? So the gradient of PQ is you taking the y value minus the y value here. So you will have fx plus h, minus the value of fx divided by x plus h, minus with the x here, right? Minus the x here. Then after you simplify, you will have fx plus h minus with fx over with h, right? X minus x, you have 0. Then it's leaving you h. So this is a gradient function, right? It's a gradient function of line PQ, right? Of line P and Q. Okay, now I'm going to asking you, what happened when this value of h, value of h here is very near to h, right? X, right? What happened? So that's why we want to teach you what is the meanings of, okay, let's say you have a graph, then same exactly this graph, then you have point P here, right? Then you have point Q here, right? So initially that you see that this line is actually a chord. It's a secant line, right? And the length of here from here, this line here is called chord. So what happened when the value of Q, okay, this is your x and this is the x plus h, right? So this point is fixed, okay? Fixed means not moving, okay? Not moving. We are fixing this point here, Alright, but one of the point is movable. Movable. So movable, boleh bergerak. So let's say Q, if I move nearer, if I move nearer here, so then I will drawing another second line, right? Now you can see that this point Q now, become this Q and this Q now become more nearer to this point here, right? Become nearer to this point here, means that the H is getting nearer here. So what happens if the Q I'm moving here? The Q I'm moving here means that this is your Q2 and this one is your Q1. So what happens if you keep moving the Q? As you see that the gradient here and the gradient here will be different, right? Will be different. So as the value of H nearer to X, what I mean here is H approaching 0. What is means of H approaching 0 here? This is a very concept. All I explained here, this is the most important one. So what is the meaning of H approaching 0? So the meaning of H approaching 0 here will be, so if H approaching 0 means that the point here getting nearer to X, right? Getting nearer to X. So it means that the value here is getting near to 0. So means that if let's say this is our Q3, let's say the point Q become here. So if you're drawing the second line, it's become, let's say if you draw the Q4, this is your Q4 and this is your Q5. If you draw this line, if you see what happened to the line here, it will getting nearer to the tangent of line. Tangent means that the tangent means, let's say tangent at P. What is tangent? Tangent is a line. Tangent is a line that touch the curve. Touch the curve means intersect only at one point. This is called tangent, right? This is called tangent because this line is touch the point P of the curve, right? At point P, touch the curve of point P at touch the curve at point P, means intersect at only one point. Intersect at only one point. So this definition here, we said that this value here, we said to be this line. This line is a tangent line, not a second line. So means that the gradient of this line can represent by f prime x. The gradient of tangent here, is f prime x. So what happened when the value of Q getting nearer and nearer and nearer and nearer to this point, right? So means that this, as the value of x plus h, means that the h is approaching 0, very near. Means that you take the difference between this point, the point x for this point and this point, as you minus x, you are getting very near to 0. X minus x, you have h approaching 0. So when it's very near to 0, very near, means that we can say that this tangent, this second line is approaching the tangent line, right? It's approaching the tangent line. Means that very small, okay? In between them, there is a tangent. There is a tangent for this graph, right? There is a tangent. So there is a tangent at this point, right? So, but when you draw as this one getting nearer, so the second line is like approaching the tangent line, right? So if you keep approaching, they will like almost converge and almost same as this line here. So this is the concept of the second line approaching the tangent line. So it means that f prime x means that this is a tangent line, the gradient of the tangent line. So the gradient of the tangent line, we're approaching the second line, right? We're approaching the second line as the point Q nearer and nearer. Alright, so as you know that, means that the gradient of PQ, the gradient of P and Q, as the Q nearer, means that the x plus h is near to x, or I can say that the h approaching 0. So the gradient of the second line will be the same as the gradient for the tangent at P. Tangent, this is the tangent. Tangent is f prime x, right? F prime x. So the second line is Q, so which is PQ, right? PQ. So as the Q getting nearer, sini, ke sini, ke sini, let's say it's a Q is here, you can see that they're almost the same. The tangent line and the second line almost, I use the word almost, approaching, alright, approaching. So means that as the gradient for this function, means that the gradient of the tangent, become almost the same. So we say that limit as h approaching 0. When the h approaching 0, when the h very near to 0, the gradient function of the line PQ, becoming the gradient of tangent here. So this is the formula for first principle. It's a very important idea here. So it's very hard to explain this thing. So it's really need to sit down and think, what is the meaning of first principle here? So means that as the value, means that the gradient for the second line, between point P and point Q will be the same as the gradient of the tangent line when the h very near to 0. Right? When the h very near to 0, these two will merge. Alright, they were considered to be exactly the same. That's why I put the limit here. Right? When h is approaching 0, the gradient of line PQ will be the same as the gradient for tangent at point P here. Alright, so this is the formula for first principle that I derive here. So I'm going to use this first principle formula to derive some basic function.